3.6 today. We're going to talk about compound inequalities. Alright, and just as you guys told me, compound is attaching two inequalities together, right? And we're going to have an and as one way to do a compound, and the other one you mentioned was or. Exactly perfect, because that's what we have in math class. An and inequality means that the solutions must work for both inequalities. So, for example, and I'm going to relate it back to English class again really quick. If I were to say it is nice outside and it is sunny, that means it's both of them, right? Okay? But if I were to say or, I could say it is nice outside or it is raining. It only has to be one of them for the sentence to be true. Same thing here. So in math, when we have an or inequality, we actually have the solutions must work for at least one. All right. So I want to start by talking about and. So what I call and inequalities. What I'm going to refer to a lot is that the solutions are sandwiched in the middle. Okay? So, for example, if I said that I have x is greater than 3 and x is less than 7, that means it has to work for both of these, right? So let's put this on a number line and see what this would look like. If I were to graph x is greater than 3, at 3, I would have an open or closed dot. It would be open, and of course, if it's greater than, it goes this direction, right? At x is less than 7, I would have an open dot, and it goes this direction. So you can see all the solutions that are going to work for this compound inequality are sandwiched between 3 and 7. That's what makes it an and. It's sandwiched in the middle. Okay? Still good? All right. So, let's talk about maybe what the interval notation might look like for this graph. Right? I bet you guys can totally figure this out. If we read it this way, we come to an open dot, so that's got to be a parenthesis, 3, and we keep reading, and we come to another open dot at 7. So if we're talking about an and inequality, the solution set, or everything that's in the solution, has to be between two endpoints. All right? Correct. If it's an and problem, it does not go to infinity. It's sandwiched in the middle. All right? So here is example number 1. Example 1, I want you to write an inequality let's just say 4. And let's talk about, let's say, the diameter of a ball is between 8 and 10 inches inclusive. All right, so all I want to do is write an inequality that represents this. So first of all, if it says between, that's going to tell you it's what kind of inequality. An and, exactly. Okay, so that's the first thing. What does the word inclusive mean? Does anybody have any idea? Right, it's including 8 and 10, right? That's what inclusive means. So when we write it, it's going to be equal to as well, right? Okay. So here's how I want to talk about how to write an and inequality. We said all of our solutions have to be in the middle, right? So I'm going to put my x in the middle. My two endpoints, it has to fall between 8 and 10. Okay? Here's where it gets a little bit tricky. I want to start with this one. Our diameter has to be less than 10. Or less than or equal to 10, excuse me. So x has to be less than or equal to 10. Do you agree? Yeah. Alright. This one, it has to be greater than or equal to 8. Well, if my x is on this side, x has to be greater than or equal to 8. All and inequalities are written with this x in the middle. Okay? But remember that you got to kind of read this one backwards, right? For it to work. Is that clear to everybody? Any questions at all before I keep going? All right. So let's try this one. Example number 2. I want you to graph and write interval notation. And I'm going to start by saying that x is greater than or equal to 3 and x is less than 9. So first of all, you heard the word and in the middle, which means your solutions have to be sandwiched in the middle, right? That should automatically click as soon as you hear that. So let's graph this. I'm going to start at 3. Do I have an open or closed dot at 3? Closed. Very good. Closed. And x is greater than, so it's going that way. At 9, x is less than 9. Do I have an open or closed dot? Open. And x is less than 9, so it goes this way. So all of our solutions are sandwiched in between those two endpoints. Interval notation. Colin, you think you got it? Okay. Uh-huh. Good. Perfect. Absolutely. All right. Still doing well? Okay. Let's try example number 3. We got to set this up a little bit, right? Example 3. Now let's solve graph and interval notation. And you guys know today when you're doing your homework that even though it doesn't say to write interval notation, if you have to graph it, you have to write it. Okay? Alright. So let's solve this one. Let's say I have 3 is less than or equal to x plus 9 less than 10. That looks funky, doesn't it? I still have my x in the middle, which means this has to be an and problem. Now, if I want to get x by itself, how do I get x by itself here? Yes, I've got to subtract 9 from everywhere. So 3 minus 9 is negative 6. Less than or equal to, I still have an x. Less than 1. Okay? So now when I go to graph this, you can, because you see it's sandwiched in the middle, right? We have a negative 6. Do you think we have an open or closed dot at negative 6? Closed. Very good, because that equals under there. At 1, do we have an open or closed dot? Open. And we're going to sandwich it in the middle. So all your solutions fall in here. Okay? So this first one, technically, if we were to read this correctly, this says x is greater than or equal to negative 6. That's why it goes that way, right? This one is x is less than 1. That's why it goes that way. How are we doing? Easy? We're liking it so far? Okay. Well, then let's continue on. Example number 4. I'm going to make this just a little harder. Okay? It'll be my last and one, and then we'll go to or. All right? Okay. So again, we're going to solve graph, and interval notation. Let's go with negative 3 is less than or equal to 2x minus 1 less than 7. Alright, so I'm trying to get x by itself in the middle, which means I got to move everything away from it, right? I have 2x minus 1 in the inside. What do you think I need to get rid of first? Add 1. Very good, Logan. We're going to add 1. If I add 1 to the middle, I have to add 1 to both ends. Because it all works together. Negative 3 plus 1 is negative 2. Less than or equal to 2x less than 8. Now, what do I got to do? Yeah, I got to divide by 2. And again, I got to divide everywhere by 2. Negative 2 divided by 2 is negative 1. Less than or equal to x less than 4. Alright, on a number line. At negative 1, open or close dot? Good. At 4, open or close dot? And we're going to shade in the middle, right? Because this says x is greater than negative 1. And this says x is less than 4. Interval notation. Starting at a solid dot, that's a bracket. Negative 1 to 4 to the parentheses. All right, not so bad, right? That's and. Are you ready to move to or? Okay. Let's talk about or. Now, just like I keep saying sandwiched in the middle for and, when we're talking about an or, remember I said it had to work for one or the other, or it only had to work for one of the inequalities? So the one thing I want to remind you of, in this one, our graph is going to be opposite. It's going to go in opposite directions. So for example, if I have x is less than 2 or x is greater than or equal to 5. Okay, I have the word or in the middle. Let's start by graphing this one. At 2, I have an open dot and it says x is less than 2, which means it goes to the left, right? I also have x is greater than or equal to 5. So at 5, I have a closed dot and it goes to the right. So every or problem, its graph is going to go in opposite directions. Okay, so instead of where and was sandwiched in the middle, this is on the outsides, the opposite ways. Okay? Alright, so now let's talk about the interval notation for this. So if we were doing the interval notation for this piece, just like we used to do, right? Uh-huh. Well, we got to just do this piece first. So this goes from negative infinity to 2 with a parenthesis. This one is a closed dot, so that's a bracket, 5, and that arrow goes to infinity. The only thing we're going to add to this is we're going to put a u in the middle, which means it means union. You're putting the two together. So we have two pieces on the graph, and we have two interval notations, or two pieces to the interval notation. All or problems fit just like that. Your solution will fall either here or here. For it to be true, it has to work for one or the other. Okay? Not too bad, right? Okay, good. So, here is example number 5 then. Example 5. We're going to solve graph and interval notation. Let's say I have 3x plus 1 is less than negative 5, or 2x is greater than or equal to 20. Alright, so let's solve the first piece we have here. We would first subtract 1 from both sides. So I have 3x is less than negative 6. Then, of course, we would divide both sides by 3, and we get x is less than negative 2. So I'm going to put that on my number line to begin with, at negative 2. I have an open dot, and this goes to the left. Now let's solve the other one. I divide both sides by 2, and I get x is greater than or equal to 10. So on that same number line, at 10, do I have an open or closed dot? Closed. And this one is greater than, so it goes to the right. Again, all OR problems are exactly like that. Okay? Interval notation. First piece starts at the arrow, so that's negative infinity to negative 2. That's an open dot, so it's a parenthesis. At 10, we have a closed dot, that's a bracket. 10 to the arrow, which is infinity, and what am I going to put in the middle? A U. Yeah, parenthesis on that end. In the middle is a U. That means union. All right, so what do you guys think? Easy? No questions whatsoever? Doing really good? Then one last example if you guys think you got it. As long as you're sure you got it. Okay. This is something totally new to everybody, so I want to make sure. Example number 6. Let's go with, and again, you guys all know we're going to solve graph interval notation, blah, blah, blah. Yeah, okay. All right, just making sure. So let's say we have 12h minus 3 is greater than or equal to 15h. Or we have 5 is greater than negative 0.2h plus 10. All right, so again, as soon as you see the word or, what's that tell you? It's going to be opposite. Exactly, it's going in opposite direction. Okay? So, first one we're going to solve here. I'm going to start by moving my h to the left. I'm going to subtract 15h from both sides. I have negative 3h minus 3 is greater than or equal to what? Good. I'm going to add 3 to both sides. I have negative 3h is greater than or equal to 3. Then what? Good. We're going to divide by a negative. So we got to use all those rules we were talking about before. H is less than or equal to negative 1. So on my number line, oops, that was a very straight number line. At negative 1, I have a closed dot, and this goes which direction? Left. Very good. It goes that way. Okay, let's go back and solve this one. I'm going to start by adding 0.2h to the left. 0.2h plus 5 is 0.2h plus 5, right? They don't combine together? Is greater than 10. Now what do I do? Good. We're going to subtract 5 from both sides. So I still have 0.2h is greater than 10 minus 5 is 5. Now what? Good. We're going to divide both sides by 0.2. And we get h is greater than? I don't know. Why did you put a negative? Okay. H is greater than 25. So on my number line at 25, I have an open dot, and this one goes to the right. Just like you guys predicted, the OR problem goes opposite, right? Interval notation. Starts at the arrow, which is negative infinity. Goes to negative 1 with a what? Bracket. Very good. With a bracket. I'm going to put what in the middle before I get to the other one? Good. I started an open dot, which is a parenthesis, 25 to infinity. All right? right? So the and problems didn't go to infinity, it just went to endpoints, right? Or problems go to infinity on both ends. And they start at endpoints. Is there any question at all? Do you like or better than and? Well, you know, it's all personal preference. All right. So I did already load this on Google Classroom if you prefer to look at that instead of your book. We are doing problems 10 through 36 even. Okay? The first one is very close to example number 1. And then after that, you're going to be solving. And again, if it asks you to graph it, you also have to do interval notation. Okay? All right.